Hello, dear viewers. Myself Ayush Gupta, and I am here by presenting before you a self made presentation on probability. I hope that it would be resourceful and enjoyable for you all. Probability. Interpretations. Etymology. Christian Huygens. Girolamo Cardano. Carl Friedrich Gauss. Theory. Applications of probability. Mathematical treatment. Relation to randomness. Definitions of probability. The sample space S. The sample space S for a random phenomena is a set of all possible outcomes. Examples: tossing a coin, outcomes S head or tail. Rolling a coin, outcomes S means sum 1, 2, 3, 4, 5 or 6. An event E. The event E is any subset of the sample space S means sum. Therefore, any set of outcomes, not necessarily all outcomes of the random phenomena. The event E is said to have occurred if after the outcome has been observed, the outcome lies in E. Observe diagram. Special events. The null event, the empty event, the event that contains no outcomes, the entire event, the sample space, sum this event that contains all outcomes, the empty event never occurs, the entire event S always occurs. Probability of an event E. Suppose that the sample space S O1, O2, O3 to On has a finite number n of outcomes. Also, each of the outcomes is equally likely because of symmetry. Then, for any event E, probability of an event is equal to Ne upon Ns is equal to Ne upon N is equal to number of outcomes in event upon total number of the outcomes. Applies only to the special case when the sample space has a finite number of outcomes, and second, each outcome is equiprobable. If this is not true, a more general definition of probability is required. Mutually exclusive events. P A union B is equal to PA plus PB. That is, the probability of P or A or B is equal to the sum of probabilities of individual events A and B. That is, A intersection B is equal to 5. If two events A and B are mutually exclusive, then they have no outcomes in common. They can't occur at the same time. The outcome of the random experiment cannot belong to both A and B. The Venn diagram is shown in the joint figure. Please have a look at it. The additive rule. In general, P A union B is equal to probability of A plus probability of B minus probability of A intersection B, or probability of A or B is equal to PA plus PB minus PA and B. Logically, you can see in the Venn diagram that there is a common part between the regions shown in Venn diagram by the A event and the B event. The probability of the total PA or B is equal to the probability of event A plus probability of B. Now you can see that the region described by the A intersection B is counted twice in PA and PB. Thus, it is subtracted for one time minus PA and PB to get the total probability of PA or B. Example, the related example is shown here. Sakasun and Moncton are two of the cities competing for the World University Games. Complement. Rule for complements. P, probability of complement of an event A is equal to 1 minus the probability of the event A. Or you can say that the complement is simply shown by P not A, that is probability of not A, that is excluding the probability of P. It is also a point to be noted here that the sum of the probabilities P complement of an event A and that of the probability of A is equal to 1. The related Venn diagrams are shown below, and you can note the important points as discussed. Conditional probability. Frequently, before observing the outcome of a random experiment, you are given information regarding the outcome. How should this information be used in prediction of the outcome? Namely, how should probabilities be adjusted to take into account this information? Usually, the information is given in the following term. You are told that the outcome belongs to a given event. Therefore, you are told that a certain event has occurred. Definition. Suppose that we are interested in computing the probability of event A and we have been told event B has occurred. Then the probability of A when event B has occurred is given by the probability of A intersection B upon probability of B. If the probability of B is not equal to 0, for which the probability of A provided B is already occurred is defined. Example: the Academy Awards is soon to be shown. For a specific married couple, the probability that the husband watches the show is 80%. The probability that his wife watches the show is 60%, while the probability that they both watch the show is 60%. If the husband is watching the show, what is the probability that his wife also watching the show? The Academy Awards is soon to be shown. Let B the event that the husband watches the show, PB is equal to 0.80. Let A the event that his wife watches the show, then PA is equal to 0.65 and PA intersection B is equal to 0.60. Thus PA provided B has occurred can be followed as shown and it is 0.75. Thank you very much. Hope you all have enjoyed it and subscribe it.